Hello, welcome to this session on harder trig equations, which follows on from the previous session on solving trig equations. Let's have a look at some examples. First of all, though, we're going to be solving equations where we've got some kind of number in front of theta. So sine n theta equals k, cos n theta equals k, and tan n theta equals k. But let's dive in, let's have a look at what we're looking at here. Get my calculator, which we're going to need. So solve cos 2 theta equals 0.643. And we're working between 0 and 360. It's important to have your range of values. So first of all, I know if theta is between 0 and 360, I'm going to change this. I'm going to call this cos of big X equals 0.643. And if 2 theta equals X, I've changed those. I've changed that to X. I'm now working between 720 degrees and 0 degrees, because X is twice theta. X is twice theta. So the range of values for X changes. Well, let's see how this works. Let's look for our principal solution. So first we know that X must equal the arc cos, the inverse cos of 0.643. So let's get our values for X. Shift cos, there we are, 0.643. And if we're working to the nearest degree, we're very, very close to 50 degrees there. So just for this example, let's call that 50 degrees. There we go. Now let's remember our cos graph, which is here. You know your symmetry. Well, 50 degrees is there, 50 degrees back in, and that's my other solution to X. So I've got 50 degrees for X, I've got 360 minus 50 equals 310 degrees. Now we've actually got more solutions because it runs between 0 and 720. So what I would do, remember the period 360, so I'm going to add 360 to these. So 360 add 50, I think 410. Add 360 to there, 670 degrees. Now remember, we need to find theta. So you find all your solutions in the coded value X. So we've changed 2 theta to X. Works like a code. Find them all first. Do not be tempted to change them and then find your multiple solutions. Always find all your multiple solutions in X first. That is very important. Now 2 theta is X. So theta is going to be half of X. So I should have 25 degrees. They're 155 degrees. Half of that is 205 degrees. Half of that is 335 degrees. And they are all my solutions between 0 and 360. First one done. So it's about maybe coding it in terms of X. And then finding your multiple solutions. Let's have a look at this one. Well, we're going to have to do a bit of rearranging here, aren't we? Just so you can see that a bit better. There we go. So if I could rearrange that to say sine 3 theta over cos 3 theta equals a quarter. I've cross multiplied there. Well, sine over cos, I think we all remember, is tan. So tan 3 theta equals a quarter. Well, let's say, okay, tan of x equals a quarter. So remember, 3 theta equals x. This is the important bit. So I'm working between, this is going to be 3 times as big. So theta, well, that just, x, it starts at 0. And then we need 3 lots of that, 1080. So let's find our principal solution. X equals inverse tan of a quarter, out tan of a quarter. Let's have a look. Shift tan, just write 0.25 just for speed there. Call it 14 degrees, just giving you an idea here. We're going to do it to the nearest degree. Now, all of these we just add 180, so add 180, 194 degrees, add 180, 374 degrees, add 180, 554 degrees, add 180, 734 degrees, add 180, 914 degrees, add 180, and it's 1094, which is too big. So we stop here. And to get all of our theta solutions, we divide these by 3. 14 divided by 3. 14, let's just call it 5 degrees. Let's work to the nearest. We're going to work to the nearest degree here, just for this example. Divided by 3, etc. 65 degrees. Now, that should give you the idea how to finish that. You'd go through, you'd divide all of those by 3. And that would give you all your solutions between 0 and 360. There's more solutions because it's tan 3 theta. And remember the effect of that stretch on the tan graph. It would be a stretch, scale factor a third, so they'd squash in and there'd be more solutions. Let's just have a look at some further examples. There we are. Sine x plus 30 degrees equals 0.2. Well, sine of y equals 0.2. We used x, so I'm going to use y here, big Y. So let's see what happens here. So I know x plus 30 equals y. So y would be x would be y. Sorry, I messed that up. X plus 30 becomes y. So what is the y value? We're just saying x plus 30. So the graph is actually, in this case, shifting along. The graph is shifting along. So what do? We just add 30 to our value. So I can have up to 390 here, and here I can have starting at 30. Right, let's have a look. So y is going to be the arc sine of 0.2. Shift side 0.2, always make sure you're in degrees if you're working in degrees. 11.5, let's treat ourselves, let's do this to 1 decimal place. 11.5. Well, that's an interesting one because that one wouldn't be in our range, so we're going to be careful with that one. Now if you remember, sine I'm going to do 180 minus 11.5. 180 minus 11.5, which will give me 168.5. 168.5. That's between 30 degrees and 390. Now there's room for another one because it goes up to 390. Remember, the period's 360, so I can add 360 to these. So 11.5, add 360. I'm not sure why I'm using a calculator for this, but 371.5. And those are my possible solutions between 30 and 390. If I added 360 to this, I would obviously be above 390. 11.5, I can't have that. Now we just move those over to x by taking away 30. So 168.5 becomes 138.5 degrees. Take away 30, 341.5 degrees. Job done on that one. So this one is based on a translation. Let's solve this final one. We've got 4x plus 5 equals root 2 over 2. And we want x between 0 and 180. Well, let's solve the equation sine y equals root 2 over 2 and see what we get. Remember, y is going to be the inverse or the arc sine of root 2 over 2. Get you a nice little surprise here. Hopefully you remember this one. Shift sine of root 2 over 2 divided by 2. Press the wrong button. And you've got 45 degrees. So y is going to be 45 degrees. Well, I only want x values between 180, so let's see what that gives me as an x value. Remember, y equals 4x plus 5. So 4x plus 5, x is going to be 10 degrees. But when we're finding a multiple solution, we always use the coded value. So I need 180 take away 180 take away 45, which would be 135 degrees. Now, 4x plus 5 is 135 degrees. So 4x is 130. 130 divided by 4, 65 over 2, so 32.5 degrees. So we're still, these 10 degrees and the 32.5 degrees are in the 180 range. If I add 360 to these y values, remember I'm using the coded values for the multiple solutions, 405 degrees, 360 add that, 495 degrees, or 4x plus 5, that's going to give me 100 degrees for x. 4x plus 5 equals 495. 490 over 490 over 4. I'm cheating here, I'm using a calculator. I don't want to make any mistakes on this. 122.5 degrees. So we're still within the 180 to 0 range of x. Well, what happens now if I add 360 to 405? I get 765 degrees as my next value of y. Is that okay? Well, let's have a look. 765 take away 5 degrees, divided by 4, and it's 190. 190 is clearly over 180, so I've got all my solutions for x. So here, with one of these, what I've just done here is I've found my multiple solutions in y. I've changed it to sine y equals root 2 over 2. I keep solving the equation. I keep working by taking away 5, divide it by 4. Take away 5, divide by 4. Take away 5, divide by 4. Until it gets too big, i.e. over 180. So there we are. We've done 4 examples. I would review these. I'd watch this again if it's not too painful. There we go. And that covers this section on solving trig equations. Thank you very much.